we've seen that pressure and volume are inversely proportional to one another and that we can write this in an equation P1V1 equals P2V2. Now let's look at two examples of questions. One where we can use this equation to solve for the answer and one where we can't. Because what you have to realize is that this equation P1V1 equals P2V2 is a proportion equation. It's comparing a gas with itself under two states. We can say the comparison state and the question state. In the comparison state, we know both pressure and volume that are associated with one another, and in the question state, we know one of them, either pressure or volume, and we need to find the other. We can only use this equation if we have two states of the same gas. Temperature and amount of gas must be controlled between the two states, otherwise we can't use this equation. Our first example is a question where we can apply this equation. 10 decimeters cubed of a fixed mass of hydrogen gas at 273 Kelvin, a pressure of 100 kilopascals, is subjected to a pressure of 200 kilopascals at the same temperature. What is the new volume of the gas in decimeters cubed? So notice it's a fixed mass of gas. That means the amount of gas is not changing. So N, amount of gas, is constant. It says at the same temperature. So T, temperature of gas, is also constant. We can't use this equation of Boyle's law unless N and T are constant. And then notice we are given a reference or a comparison state. The volume, 10 decimeters cubed, when the pressure is 100 kilopascals. So we could call that V1 and P1. And that's our comparison state, and we're going to, in effect, be using proportion to compare that state with our question state, pressure of 200 kilopascals, and we want to know now what's the volume associated with that. So 200 kilopascals is P2, and we need to know the associated volume, V2. So we're going to use the equation, we substitute the values, we find our answer, we know that the unit is decimeters cubed. Why? Because in the question, V1 was given to us in decimeters cubed, 10 decimeters cubed. And whenever we use this equation, the unit of pressure on both sides of the equal must be the same as one another. The unit of volume on either side must be equal to one another. So V1 was in decimeters cubed, V2 must also be. Now let's look at a question where this equation cannot be used. Calculate the volume of 132 grams of carbon dioxide at a pressure of 9 times 10 to the power 5 pascals and at a temperature of 300 Kelvin. Why can we not use P1V1 equals P2V2 here? Because we have not been given a comparison and a question state. We're only given one state, a gas under one condition of amount, pressure and temperature, and we've got to know the volume. So we can't solve this question with the equation P1V1 equals P2V2. Later we will see how we can solve this question, but right now we can't yet. So we've seen that pressure and volume are inversely proportional to one another. Decrease one and the other increases by the same factor. So we can say pressure is inversely proportional to volume. But remember, pressure and volume are unusual in that they both cause the other one. So there's a two-way relationship. Not all variables are like that. So volume is also inversely proportional to pressure. We started off asking the question, how does the pressure exerted by a trapped gas affect the gas's volume? And our answer to that is the volume of a trapped gas is inversely proportional to the gas's pressure. And by saying this, we imply that all other important variables are controlled. So this is only true if the amount of gas is constant. Well, if it's a trapped gas, it can't change. And it's also only true if the temperature of the gas is constant. Although that's not mentioned here, it is implied. So we can say this mathematically in these two ways. Volume is inversely proportional to pressure, and pressure is also inversely proportional to volume. Let's take the top equation and simplify it. Let's multiply both sides by volume to clear the fraction. That gives us PV is directly proportional to 1. What does that mean? Does it mean PV equals 1? No. But what it means is that P multiplied by V will always give us a certain value. What that certain value is depends on those other variables that we've controlled. temperature and amount of gas. But for a particular situation, a particular amount of gas trapped and a particular temperature, however you compress that gas, its pressure multiplied by its associated volume will give a certain value, the same value always for that particular situation. So we can write that as PV equals K. In this case, K was 5. K is not always 5. And later we'll get to see how one can calculate a universal constant. Finally, let's plot pressure against volume. And we find a hyperbola because pressure and volume are inversely proportional to one another. And whenever you get inverse proportion, then it gives you a graph like this, a hyperbola.